Wait. Here, I have grade 11 book with me. This is my grade 11 part 2. Okay. Now, it is here. I'm not teaching something new for you people. See, it was explained here. See, in grade, I don't know whether you are able to see or not. See, are you able to see these figures?
Yes, sir.
Yeah, they are representing. This is the wave. This is there. Wait. And this one. They represented this. Sorry, they represented this one on this one. Same thing. See, I don't know whether you are able to see or not.
Yes, sir.
Did you get it? So this is the same thing. This is see, that's what I'm saying. Grade 11 and 12 is not a different class. It's actually integrated thing. Okay, we are all connected to each other. Now, this comes from simple harmonic motion. Okay, we are okay. Forget about it. Now, simple harmonic motion is what? Okay, this is a simple that is a to and fro motion. Okay, yeah. First of all, oscillatory motion is to and fro motion is a simple harmonic motion, and sorry, oscillatory motion. Simple harmonic motion is a special case of periodic motion. Special case of a periodic motion. So, okay, now what is happening? We are representing. Suppose this is a wave particle moving on a circular on the circumference of a circle, but we are representing this on the waveform. On the waveform. So this diagram is known as phasor diagram. This is known as phasor diagram. This is known as a phasor diagram. Is that clear? Understood now? Representing, you can write it there. Okay, I don't have space. Representation of a circle on a wave is known as a phasor diagram. Representation of a circle on a wave is known as phasor diagram. Is that clear? Now what I am doing now, see here. When the particle is here, from here, started from here and it is stopping here, it is 90 degrees, right? See here. Is it not 90 degrees? Is it not 90 degrees pi by 2?
Yes, sir. Yeah, yeah.
Now suppose if the particle is here, suppose it started from here, what is the angle now? How much will be the angle from here to here? From here to here, how much is the angle?
180.
180 degrees. Is not d the 180 degrees? See pi. Is it not 180? Yes. Now,
Yes, sir. Yeah.
E now. How much is the angle now? From here to here, it is how much? 270 degrees. Understood now? See, is it not 270? 3 pi by 2. Is it not 3 pi by 2? See, 270 degrees. So if it completes one rotation, it becomes 2 pi. Is it clear? It becomes 2 pi. Is it not the same?
Yes, sir. I had forgotten about this. Now I remember.
Yeah. Is it clear now? So we are representing a circle on a wave that is known as a on a waveform. Is that clear now? So this type of diagrams are known as phasor diagrams. This is known as a phasor diagram. Maybe you might have forgot the word phasor diagram. That is a represent. Maybe students will remember this one unless and until we just recap it. Okay. Okay. So just take a picture. I'll take a picture and send it to you. Just go ahead. So is it clear, all of you know?
Yes, sir.
Okay, so I'm going to draw the phasor diagram for resistor now for the first one. Okay, so the other capacitor inductor will be easy once you understand this one, the concept. So you can yourself tell when I'm drawing the diagrams itself, you will tell what is the angle and all. So the first thing will take time. The first diagram will take time. The second will not. Second and third will not take much time. So now, what is happening now? See here. So when I'm drawing the phasor diagram is like this. See here. The voltage is like this, and the current is like this. This is the voltage, and this is the current. This is the voltage and current. Okay. Now this is 0, pi by 2. This is pi. This is 3 pi by 2, and this is 2 pi. Is it visible for you? Dhruti and all.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So this is 0, pi by 2, pi, 3 pi by 2, and 2 pi. You can see here the amplitude of current is less and the amplitude of current is voltage is more. Why? Why? Because some amount of current is converted into what? In resistor, it is converted into heat energy. Is it not? In resistor, some amount of energy is converted to heat energy. That is the reason. Okay, anyways, we are not going to discuss. So here, again, this is the voltage. This much is the voltage of the voltage, and this much is the voltage of the current. Okay, this is the voltage of the voltage and amplitude of the voltage and amplitude of the current. Now, when you are drawing the phasor diagram, this is the waveform. This is known as waveform. This is waveform, and the phasor diagram is like this. See here, the phasor diagram. If you see here, I'll draw it here. Better. The phasor diagram is like this. This is voltage and this is the current. Because both are having the same angle. Okay. Both are having the same angle. Same angle omega t. Theta is equal to omega t. Now what is the voltage? The voltage of the current is this much. Sorry, amplitude of the current is this much. This is Im. This is Vm. Amplitude of the current is this is Im and this is Vm. Is that clear? This is a phasor diagram. This one is a phasor diagram. Is that clear?
Yes, sir.
Yes, sir.
Okay, I'll just ask you 4 more questions. What is a phase? Phase, PHAC, phase. What is a phase? What is a phase? Out of phase, constant phase difference. Alright. Phase, in phase, out of phase, constant phase difference. Now then, don't tell me, sir, it was not taught. Okay, so it was already taught in your grade 11. Everyone.
The phase is the point where the point where time is represented on a waveform.
Hmm. What is your definition? Abid Arham. What is phase? This is
Yes,
very
sir. So
important again.
so phase is the 360 degrees. Um,
Arham, what is phase?
Uh,
Try. Phase.
so it's a certain point where time.
Okay. Yeah, phase of life. Okay, we say no. I'm going through a phase of life, difficult phase of life. Yeah. Phase is represented by 5. Okay. What is phase? It describes the state. This is also in grade 11. Okay. State of motion and direction of a particle. It describes the direction of state of motion and direction of a particle. Or we have simple definition also. Angle made. The second definition is angle made with its initial position. With its initial position. Angle made with its initial position is said to be phase. Okay. Now we'll discuss about in phase, out of phase. Okay. What is in phase? First is in phase. In phase means if both the waves, if the angle between both the waves, see like this. If this is y1, this is y2, the angle, the phase difference is 0 degrees. The angle between both of them is 0 degrees. Means in phase. In phase means you are watching the movie and you are understanding the movie at the same time. That means you are in phase. Understood? You are in phase. You and your friend walking on the beach. Like suppose example, your left leg and his left leg moves at the same time. Best example for this is Republic Day parade. In the parade, you might have seen all the soldiers marching. How they march? All the left legs, all the right hand together. Have you seen this one? Anytime Republic Day parade?
Yes, sir.
So that is the best example of in phase. They are in phase. Okay. Now out of phase. Out of phase means what? Out of phase. Out of phase means angle is here. Angle is 180 degrees. See, this is y1. This is y1, and the second one is y2. Angle here is 180 degrees. Suppose you want to go with your friends to a maybe to a picnic or to a something, and so you asked your parents, and suddenly they denied. You are in a very joyful mood, and suddenly they denied. No, you're not going to go. Just giving example. Then what happened? Your face will change completely. Your good mood will be spoiled. Okay, you will be in a bad mood suddenly. So that is 180 degrees out of phase, completely out of phase, 180 degrees. Teacher scolds you in front of everyone. You are in a good mood. You're out of phase completely. You are sad now. So that is out of phase. Is that clear? 180 degrees. Then what is a constant phase difference? A constant phase difference means every time they are like suppose like this. Yeah, this is the thing. Okay, so this is y1 and this is y2. So what happens? Every time this is a constant phase difference. You understand, suppose the teacher is teaching the class, you understand after 2 minutes or after 1 minute. Oh, it's like that. I understood now. Like that. Means every time it is going 2 minutes delay. I started my class, suppose the train has to start 8 a.m. 8 a.m. But the train started 8:10 a.m. The second and it has to maintain a constant speed. It has to reach the second station at 8:30, but instead of 8:30, it will reach 8:40. It has to reach the destination 10 a.m., but it will reach 10:10. Is it not? Do you understand now?
Yes, sir.
So every time there is a constant phase difference. This is the initial one. This is the constant phase difference. So that is why sometimes we say my computer is lagging. My computer is lagging. Or my laptop is lagging, or my mobile phone is lagging. Is it not? We use the term. What is lagging? It has to go with that. The pulse is given proper time, but the phone is going, the software or the app is not working properly. So we can say in simple words, leading or lagging of a wave. Leading or lagging of a wave. Leading or lagging of a wave is known as what is a constant phase difference. Is that clear? Is known as constant phase difference. Is that clear now? Is known as
Yes, sir.
constant phase difference. Is it clear all of you?
Yes, sir.
So, this completes your first part, okay, resistor part. So tomorrow I'll be doing two part, that is two topics. One is capacitor thing and one is inductor thing. I think we can do it faster also because now you got the concept. Is it clear now? What is in phase? What is out of phase? What is constant
Yes, sir.
impedance? You know what is a phasor diagram now? Okay, how the phasor diagram works, and you know what is a pulse? V is equal to Vm sin omega t. You know I is equal to Im sin omega t. So it won't take much time for me to explain inductor and capacitor. It will go faster. Okay, just go through this one. These are all the basics which you studied in grade 11. I have just done a recap for you or a revision. I have done just a revision for you from grade 11 thing. So don't think that grade 11 topics will not be used in grade 12. It will be used directly or indirectly. Okay. So we'll stop here for today. And okay. So for the other classes, I'll give the timings. Okay. Any doubts?
Okay, sir.
No, sir.
No, sir.
Yeah. Okay.
Okay, sir. Thank you, sir.
Yeah. Thank you so
Okay,
much.
sir. Thank you, sir.
Thank you.